All right, let's get started. Make sure I'm live. All right. So I'm using a different mic today. I've been playing around with my other mic. It's kind of not disassembled, but it's not, it is missing from the, it's not there. That's where it is normally. So I'm using my wireless DJI mic. So the only thing I have to do is make sure I remember to take it off when I go to the bathroom, because that happened to like the Supreme Court of the EOS. One of the justices was wired for sound and then went to the bathroom. Luckily, it was just number one. So welcome to the beginning of the stream here. So my I've got a pretty good set of slides going, 39 slides. So generally when I'm doing a course, I time slides for anywhere between 2 to 5 minutes. So this is already well over an hour of content, probably closer to 2. It kind of depends on the slide. And I like to be very disciplined about and very making the slides when they need to be made. I do whiteboards, but I'm of the opinion that if you're going to do, if you do a whiteboard 5 times, it should be a slide. Because slides with the animations are going to be more legible, you can explain more. Whereas whiteboards, I think, should be kept for things that are dynamic and questions that aren't in a, the answer is not in a slide. But if you get asked that question enough, or even just if you get asked a question once, it should be a slide. And when I say slide, I mean a slide like this. I don't mean a slide like this. Like I try to not do this type of slide all that often. I try to do slides like this because networking, you can think of it as networking illustrated. All right, so we talked about uneven distribution, and another concept when we're talking about link aggregation is asymmetric hashing. So the nifty thing about link aggregation is it does not require that you use the same hash on both sides. It can be, it's completely different in each direction, independent in each direction. They do not need to match. In fact, they almost never do if you have 2 different pieces of hardware, even if you have 2 different pieces of hardware with the same vendor. So let's say these are 2 Cisco switches, but there are different models. Like one's a 93-180, one's a 93 FX. One's an FX3. The chips might do slightly different things when it comes to how they compute the hashes. It's a bit of a mystery in terms of how the computations happen, because there's no standard for how you divide traffic up. So the link aggregation standard says just deliver things in order. Actually, I don't even know if it says that, but just have some way to make sure that related packets go over the same link because of the aforementioned in-order delivery problem. So in one direction, it may look like this. Do we have any animation? Nope, we don't. Okay. And I'll do... There's like a left to right one. Does it fade? Select options. No, that's not it. Emphasis, transparency, object color, line color, complement. Zoom, swivel, random bars, grow, split, float in, fly in, fade. Or wipe. That's it. So we want to do a wipe. From left, yeah. There we go. Nice little animation there. And then I'll do a different color on the way back. And so which one did I use? This one, I think so. This, this. There we go. And then we'll do a different color. Yeah, I don't want to fill it. So no fill. And outline, we want it to be 6 points. And I want it to be something bright. Do that. And I need to put an arrow at the end. There we go. And then this one will also be a wipe. And it will be from the right. So when I'm making this point, it'll be the hashing mechanisms on each switch is independent in each direction. So for example, switch 1, if it's the same flow, switch 1 could send it over this path, and then switch 2 can send it over that path. And they could have two completely different hashing mechanisms. So this one might be hash of L2 and L3 headers only. So do a animation up here and up here. So traffic comes from host 1 to host 2, host on the left, host on the right, and it gets hashed on that path and then coming back. Now they're independent, so it's very common that traffic flows are going to be asymmetric, because switch 1 could be a hash of layer 2 and layer 3 headers only, and then switch 2 could be a hash of layer 2, layer 3, layer 4 in VLAN headers. So they are independent in each direction, and they often do not match. They don't have to match, and they often don't. Unless it's the same switch with the same hardware, with the same setting, they probably will not match. Or there's a good chance that they won't. Because each chip might do, even in the same vendor, each chip might do a slight variation of how they compute the hashes. And honestly, it's kind of a mystery as to how they do it, how they do the computations. But it doesn't matter. There are some exceptions. For example, ACI has an interesting feature. It's really badly implemented, but it's an interesting feature where you can build out these scale-out firewalls. They're all active. And the trick about firewalls is traffic has to come in and out the same firewall, because unless we maintain a shared state table or shared session table. But because you're using the same hardware, it'll guarantee that the hash goes to each switch. So it's ECMP across the firewalls, and the return traffic gets hashed the exact same way. So you can have 16 firewalls, and traffic will go through each firewall, and the return traffic will come back through the same firewall. And the firewalls don't have to know about each other. They don't have to have they should have the same policies on them, of course, but they don't need to share a similar TCP state table or even a connection table, because they just handle their own connections. They don't get someone else's connections. Unless there's a failover, in that case, probably drops the packet, but that's normal. That's what happens anyway. All right. So got even distribution. Okay, so the next thing we need to talk about is we're going to talk about so MLAG is the next technology. Or we should go back to spanning tree. Yeah, we should go back to spanning tree and talk about how that works. There's a couple things we should talk about. You know what? Never mind. I'll do mlag first. I'm feeling resistant to doing any talk about spanning tree right now. About mlag. And then what is mlag? It's known by many names. So VPC, Cisco Nexus, mlag, Arista, MCLag, which is also my rap name, Juniper. Who calls it VLAG? I don't remember which. Is it IBM? NVIDIA. Who calls mlag VLAG? Pluribus. Apparently Arista used the term. Pluribus. I don't think I know Pluribus. They still, what do they do? I'm embarrassed to say I don't know Pluribus. I've heard the name. But I guess they're not, their website doesn't do anything, so I'm going to take that out. Takes two switches and presents them to a host to another layer 2 device as a single switch. Shares a spanning tree bridge ID, shares an LACP system ID. And the way that I draw this, typically, when I whiteboard it, and I'll do it here, is have a switch 1 and switch 2. And I'll get the yoink. Cutting and a pasting, cutting and a pasting. Group this. Send it back. I need my mlag domain dotted lines. That's what I typically do for an mlag domain. Keeping a consistent visual language as best I can. I think I've talked about this before. I used to do courseware content creation, courseware creation for Cisco back in the 2010s. And they were fanatical. Is there a GitHub link available to this series? No, there's not. But what I'm going to do is once I make these slides, I'm going to record them and put them on YouTube for free. So Arista acquired Pluribus. Okay, that's why. What did they do? What did Pluribus Networks do? That's where I remember the name from. I don't think I ever taught them. Weird. They bought up all these weird, because I taught Big Switch for a little while. So Arista bought Big Switch and it became the converged cloud fabric and the DANS monitoring fabrics. And I taught that for a while. But I hadn't taught it in quite some time. So I don't know if they just stopped training for it or not. Do they still have the DANS monitoring fabric? Looks like they still have it. I don't think they've done anything with it. A lot of companies are not very good at absorbing other companies. That's weird. I don't know what they did with Pluribus. I never saw it. It never came across. And I was teaching for Arista. Well, for SCM Pros until SCM Pros collapsed. That was an epic implosion. All right, so, and then a host. I typically do host in green. There we go, link aggregation. Center it. Center this. There we go. So MLAG, known by many names, takes two switches and presents them to another layer 2 devices. And then I do, again, this is the way I do it, my signature method. So make a little thinking cloud. And then I draw a little topology. So I'll move this up. So I can have some room. So what it thinks is happening is it's got one connection to two different switches, or to one connection to one switch. All right, it's going to have a problem with the colors here. So I'm going to need to do something so it's not a white background, or I need to darken the colors. So one of the, I'll leave it like this because it's not a big deal. But one of the tricks that I use to handle stuff like this is I make another square so I can link it. So they're going to be connected, but I don't need to do that here. I'll just set this to back. Send this to front rather. Bring to front, bring to front. And then I can either make the square or make the thinky thing. Let's try making this darker. No, not fill, outline. Yeah, that'll work. Or I could do, just make this a little darker. Quick styles, shape fill. What looks brain-like? Do that. All right, there we go. That'll do MLAG domain. So do another slide. MLAG fun facts. MLAG is vendor specific, proprietary. There is an open MLAG standard in 802.1 AX 2014 called DRNI. DNRI or DRNI? IEEE MLAG. Can't remember what it's called. Let's look it up. DRNI MLAG. Yeah, so I guess DRNI, IEEE. Distributed Resilient Network Interconnect. But only HPE supports it. I think it's just HPE, yeah. Cisco, Arista, Juniper, etc. use proprietary implementations. Arista will swear up and down that they don't do it proprietary, but it's proprietary. And then people get really bent out of shape about the word proprietary. I don't think it's a bad thing because the proprietariness, I should make an entire slide on this. MLAG, proprietary MLAG is boundaries. Proprietary MLAG boundaries. Because it's only proprietary within that domain. So group these. Shift, stretch, then do that there. I can make these a little bit bigger too. Hoping my audio sounds good. I'm using my DJI mic. So, oh yeah, put in the wrong place. X. So outside, I'll do 2 call outs for this. You know, I should just do this. Some very weird group behavior. Outside of the MLAG domain, it's standard, it's networking standards. 802.1q, D, VLAN. So MLAG and VPC and MCLAG is only proprietary between these two switches. Between two switches in the MLAG domain. Because there is a proprietary protocol running between the two. So animation-wise, I'll do this, then this, then this. So the boundary, so proprietary gets used, you know, proprietary is almost a pejorative in networking. And that's mostly good, but I think people get bent out of shape about even the concept of proprietariness. And what I think it is important to know is the context. You know, there's always going to be something proprietary, like your fans on your switches are proprietary to that vendor. So you're not going to be able to use a Juniper fan for an Arista switch and vice versa. And that's, you know, it's just normal how things get built. And in case of MLAG or VPC or MCLAG or whatever vendor is using it, it's only proprietary in that side of that domain. Just those two switches, that's it. So there's a proprietary MLAG protocol running between the two switches, but everything outside of those two is speaking normal networking standards. So 802.1q for VLAN tagging, 802.1d for Ethernet forwarding rules and for spanning tree, and just general Ethernet frames, etc. So outside of it, it's normal, whatever, you can connect any device to any device. It's only those two devices. It also brings out some limitations. So some MLAG limitations. So I'll just move this off to the side. Then I'll make this, I'll change the layout to bullet points, and then I'll put the bullet points off to the side. So when I do bullet points, I try to include them unless they're really dense. And I don't have a problem with bullet points like this, as long as they're not very common. But I can also try to do stuff like this just to have something pretty to look at. This is the arm candy. So MLAG limitations must be same hardware models. So Arista and most of the other vendors that do MLAG or some, you know, VPC, MCLAG, etc., they don't support different hardware versions. So even if it's like a hardware revision, like a 7280R versus a 7280R3, like they couldn't be in the same MLAG domain. Must be supported versions of EOS, of NOS, Network Operating System, because this is not, even though this is going to be an Arista-based course, and again, I'm not affiliated with Arista anymore, even though this is going to be an Arista-based course, this is a limitation that all the vendors have. Must be supported versions of NOS. Must be same versions of NAS. And upgrades may need to be need to have intermediate steps. For version 1, version 1.2, version 1.89, for example, just as an example. So those are some limitations. That's why people tend to, it's one of the benefits of using EVP and VXLAN is you can use a different method of this multi-homing called EVP and all active, or EVP and ESI, depending on where you heard it from. I'm gonna go and check. As a side note, I'm checking the tracking information for my laptop. So I ordered a new laptop from Apple. Oh, it just arrived in Shenzhen. It was made in Vietnam. I ordered a custom arrangement. It's an M5 MacBook Air, and I got a 32 gig version with 2 terabytes of disk. And a friend of mine got me a hookup, so thank you for that. So I got a little bit of a discount on it. But because I custom ordered it, when did I order this? There's just, I mean, I'm not blaming Apple for this. Yeah, I ordered this May 19th. So I guess not too long. How many weeks is that? 1, 2, 3. May 19th, 2, 3, 2, 1, 2. Yeah, it's not that long. But because I ordered an uncommon combination of RAM, I maxed out the RAM, and I did 2 terabytes for the disk because I'm using it for video and photo a lot. So I wanted to have the space for it in the memory. Because the only thing that does that eats up that much RAM is video editing. All right. Okay. So MLAG limitations. Then setting up MLAG. So do we need probably need a checklist. One, choose peer link. 2 links. 2 front-facing links. Ports as links. Oh, another type for MLAG is back-to-back MLAG, also known as a bow tie. Because we can configure a bow tie move this down here. Three and 4. Then we have Create a photorealistic image of a bow tie in a pastel color. Pastel green with a fully transparent background. So this is a bow tie. Two switches in an MLAG domain can connect with two other switches in an MLAG domain. The two switches inside the MLAG domain must be same vendor, software, hardware, but two different MLAG, VPC, MCLAG domains can connect to each other. This is better as a picture with some callouts. So this could be an Arista MLAG domain. Cool. What'd you do with it? Place the bow tie into the slide. Could you just give me the image? Oh, Copilot. Why are you so dumb? All right, I'm gonna grab some more coffee. Actually, I'm gonna take a restroom break, and I'm remembering to put this down. Be right back. There we go. Oh, Copilot. Make it an actual transparent background. I feel like Copilot got a lot worse. I mean, it was pretty bad, but now it's just now it's just garbage. I'm not worried about I'm not worried about AI taking over our jobs at this point. So yeah, so back-to-back MLAG. The two switches inside the domain have to be the same vendor, have to be the same NAS, have to be the same hardware. But you can attach one domain to another domain because it looks like, I'll just copy this. Because what it looks like to both sides, are you freaking kidding me? Start over. Make a photorealistic image of a bow tie in pastel green with a totally transparent background, and let me move the image into the slide myself. Lots of typos there. So yeah, this is what it looks like. It's just one switch with 4 links into another switch. Okay, back to back. Going into my system. What the heck? Where is agent turned 4 workspace output? Where the heck is this? Do I have this in like OneDrive? Copilot, why are you so bad? It's like I'm placing in. Oh man. Okay, so what is MLAG? MLAG fun facts, proprietary boundaries, limitations, back-to-back MLAG, and then setting up MLAG. We will do a bullet slide for this, or at least I think we will. Yeah, so choose peer link, 2 front-facing ports as as a port channel. Use LECP. Choose a peer link VLAN ID. Typically 4094. Highest VLAN ID, highest usable VLAN ID. It can be other. It can be any valid VLAN ID. Typically, VLAN. Still working on it. Oh my gosh. I should do a series on like Copilot fails. Well, I mean, that's pretty freaking terrible, but maybe I'll have ChatGPT do it. I'll do it in a different window. Because I pay for ChatGPT. Make a photorealistic image of a bow tie in pastel green, a transparent background in PNG format. See how long that takes. All right, setting up, so we need a peer link. Create SVI on peer VLAN /30. It used to be need to be a /30. I think you can do a /31 now. Copy image. See, that wasn't so hard. And then I'll just crop this. And then, yeah, so back-to-back MLAG. So I can take one MLAG domain, maybe it's Arista, and connect it to another MLAG domain, or VPC domain in this case. And then I connect them across the 4 links. We call it a bow tie because it kind of looks like a bow tie. God, you're terrible. Up here. So I could do a back-to-back MLAG. So I could take a switch domain, so 2 switches in an MLAG domain. Where's the MLAG domain? 2 switches in MLAG domain, and I could take 2 switches, maybe a different vendor. In this case, it's Cisco VPC, same thing. And then I can connect them to each other. And what they see is 2 switches connected to each other across 4 links, but it's really 4 switches. We call this a back-to-back MLAG, or we call it a bow tie because it kind of looks like a bow tie. There we go. That slide is done. Setting up MLAG. We need to choose a peer link. Let's do this. I'm going to do, yeah, let's do this. So I think I can do this as a list. Yeah, so I'll do this as a peer. And then I can do a effect options, timing, triggers, start and click, start and click, start and click. So they show up one by one. Although I think I'll do start with previous and then start with previous. So choose peer link. So these are going to be 2 front-facing ports as a port channel. Use LECP. So then I'll do these guys. Well, first of all, I need to ungroup this. And then I'll appear these. Yeah. So you're going to choose a peer link. So we want to pick 2 front-facing ports as a port channel, configure them in a port channel, and we're going to use LECP. Then we're going to pick a peer link. I'll put that in as a some kind of object representing across the 2. And I'll make these, I'll change them to bottom, or it's top. I'll move them up to the top. So VLAN 4094 across them. And then they'll appear. Choose a peer link VLAN ID, typically 4094, and then create an SVI on peer VLAN. So I'll do that as a one of these. Now the question is, can I make them /31s now? I think the newer code can. So we're gonna play with that. MLAG configuration, interface VLAN 4094, interface VLAN 4094, IP address 10.1.255.0, auto state, MLAG configuration, peer link, interface show into port channel 10. Interface E1 through 2, channel group 10, mode active, interface port channel 10. Switch port, mode trunk, switch port trunk allowed, VLAN 4094. All right, back to MLAG config, port channel, peer link port, should be port channel 10. And then peer address 10.1.65.1. What else do we do? Interface, local interface, VLAN 4094. Yeah, I think that does work. I have a vague memory of it not working as a /31 in older versions. I do have older versions. I could try them out. And 1.255.1. Auto state. Face. Oh yeah, E1 through 2. Show VLAN. Channel group 10 mode active. Port channel 10, switch port mode trunk. Trunk allowed VLAN 4094. And show interface port channel 10. Link is up. And what do we want to do? We want to got the IP address configured. Can I ping the other side? 10.1.2.250? I can. MLAG configuration, MLAG domain. Domain ID of MLAG. Peer link, port channel 10, peer address 10.1.10.0, local interface VLAN 4094. Peer address must be in the local interface's subnet. Maybe that's what was wrong. It's 4094. And one. Oh, yeah. Peer address 10.1.255.0. Local address VLAN 4094. Okay, it's up and running. So it does work with a /31. I'm curious now, and this is the time to be curious. Mount. All right, so I'm going to go to so SFTP local system here. I've got a bunch of network images here. I'm going to get the oldest one I can find on here. I know I've got even older ones. What do I have? To see if there's an older version that does not support /31s. /28. Yeah, 28 is the oldest I've got. I don't know why that did that. All right, let's go ahead and put 28 on here so I can just copy this over here. Do I have it on here? I don't. 29 is the oldest one here. All right, it's uploaded, and then do sudo docker image import CEOS lab as CEOS 4.28.13. We'll just call it that. So it takes a second to import this. So what I'm going to do is I'm going to shut down this this lab. Really. We'll change this from 36 to 28. There it is. So sudo docker image ls. Change all occurrences. All right, and then we'll go into CLab destroy. And deploy with the older version. Takes a second here. Looks like my stream is doing 10 megabits per second. It's easy on the codec because most of the stuff doesn't change. It's a pretty static environment. Except for this window here. I can't get out. I can't get out. I'll just quickly set up the nodes again. If 1, 1 to 2, channel 10 mode active, port channel 10. Yeah, they do VLAN 4094, interface port channel 10, switch port mode trunk, switch port trunk allowed VLAN 4094, interface VLAN 4094, IP address 10.1.255.0. No auto state. So what no auto state does, if you do show interface brief, I show interface, I'll get to VLAN 4094. It's right now it's up, but if it was down, if there was no interfaces that had it active, it would shut the interface down. So no auto state means just leave it up all the time, unless you do a no shut. And then show VLAN, switch port trunk allowed VLAN 4094, MLAG configuration. Okay, interface VLAN 4094, peer address 10.1.255.1, peer link, port channel 10, lag domain, domain ID and lag. Go to the other one, 2. Channel group 10 mode active. So it turns on a port channel and LACP. Interface port channel 10 is going to be switch port mode trunk. Switch port trunk allowed VLAN 4094. VLAN 4094, put it in the VLAN database. Interface port channel 10, switch port trunk. I'll show VLAN, make sure it's in there. Switch port trunk allowed VLAN 4094. That's interesting that it didn't take. No, it did take, never mind. I'm blind. Interface VLAN 4094, IP address 10.1.255.1. Okay. MLAG configuration, domain ID MLAG, peer link, port channel 10, peer address 10.1.255.0, peer local address, local interface, VLAN 4094. Yeah, I guess you can, yeah. At least that far back. I think that's as far back as I need to go. What is the oldest version of EOS supported? Arista is pretty brutal about their support. And I appreciate it. I like it. They support their software for 3 years. And that's it. So I think this is more than 3 years ago. Yeah, 3.1 is the most is the oldest supported. Yeah, for 3 years. Which, you know, that seems short, but honestly, it's good for them. Okay, so the reason why I did that is I didn't want to put it in there that you can do a /31 and then people try to do a /31 and it causes a problem. Maybe I'll put it like some older versions may require a /30 because I'm almost positive I ran into that at one point. Yeah, let's check my old GitHub repo called Tony Burke Automation. This is used to be my instructor one that I used, that I linked students to. For when I was teaching for SDM Pros. And then I had, I'll search this, because there were some files called mlag left. I think this is, someone used mine, which is fine. That's what I put it up there for. Yeah, this is my my L5 class repo. So I think I taught this person. Yeah, so I'm pretty sure I did this, and they cloned my repo, which is what I wanted them to do. Yeah, so at some point the software I think required a /30 or bigger, but now they can do /31. You can also do IPv6. I've done it with IPv6 before, with a 127, which is real weird. Okay, so what was I doing? Choose a peer link. So we connect the two switches to each other. Oh yeah, we want these to appear. So do 0/31. domain ID, and any alphanumeric, numeric, any alphanumeric word. String. How these appear. Okay, so checklist. We've got two switches. We're going to put them into an MLAG domain. So first we choose a peer link, two front-facing ports as a port channel. Then we choose a peer link ID, a peer link VLAN ID. Typically we use 4094, which is the highest usable VLAN ID, but it can be any valid VLAN ID. I mean, don't use VLAN 1, but any of the others will work. So here we picked VLAN 4094. Create an SVI on the peer VLAN. So each side's going to get a /31. It can be bigger than a /31. A lot of people use /24s, but use it there. And then, but some older versions may require a /30. Nothing supported today. So I think 31 is the oldest supported version, or 30 maybe. And then we configure a domain ID. So it can be any alphanumeric string. We'll choose MLAG. And then there's MLAG overlapping values and MLAG. So this is an interesting thing. So we're going to group this together, just so we can shrink it just a tad. Three and switch 4. I did a dual connector at one point. Let me find that. Yeah, this one right here. Strange thing. That's not what I wanted to copy. So you can reuse SVI IPs and domain IDs. Actually, this would be probably up here. My mlag VLAN, mlag peer links and VLANs do not go beyond the mlag domain. The VLAN 4094 does not traverse that link. Where's my X's? Where are my X's at? All right, I'm going to grab some water, and I'm going to take my mic with me, and I'll talk about it. So the nice thing about the configuration here, so in Cisco VPC, so if you're familiar with the Cisco world, with a Cisco VPC, oh, I'm out of spicy water. So I have a soda stream. So the noises you're going to hear are going to be the soda stream while I fill this up. So in Cisco VPC, their domain IDs are integers, and that's how they determine the shared address that they use. Just the soda stream filling up there. Whereas Arista uses a different mechanism, so it's just a label, and you can overlap them, and it's fine to overlap them. Roxy, yeah. Sure, it's the soda stream. I hate to think what else would make that noise. Okay, so the outlook for this one. So we'll do this one. Animations. This one would appear. And then this one would appear. And then, for example, the VLAN 4094 does not go across. Okay. So here we've got two different switch pairs. So we got switch 1 and switch 2 on the left. We got switch 3 and switch 4 on the right. You know what? I should probably do a call out to that. So let me grab a call out. Just to highlight. Because there's a lot of text on here, so it can be easy to miss them. And then I'll do a call out for the VLAN ID. here, and here. And this here. I hate when he grabbed the wrong thing. I'll just get rid of all of these because otherwise it's going to be a mess. Okay, so you can reuse peer VLAN IDs, SVI IPs, and domain IDs. So we've got, so this one will appear. And then we've got two setups here. So we got switch 1 and 2. And then this is different, switch 3 and 4. So they both have the same peer VLAN IDs. Oh, when I also need these two, I need to, oh, shoot, do the start over again. Up here, same switches, up here, disappear. We have the same VLAN IDs, appear and disappear. Same SVI IPs. Will disappear. And the same domain IDs. Appear and disappear. And then this thing will come up at the end. Okay. Oh, appear and appear. Okay, so we got two different domains here. So these are, and we can reuse our VLAN IDs. Let's do this. Oh yeah, they're not disappearing all the way. Yeah, I didn't, this one disappears. Let's try this, okay. So I've got two different MLAG domains here. The first one is switch 1 and 2. The second one is switch 3 and 4. And we can reuse peer VLAN IDs, SVI IPs, and domain IDs between different MLAG domains. For example, they both use VLAN 4094. They both have the same sets of /31s, and they both use the same domain IDs. And the MLAG peer links and VLANs do not go beyond the MLAG peer, so we can overlap them because VLAN 4094 does not go between them. We're not extending VLAN 4094 beyond the VLAN, the MLAG domain. So make sure you don't do that. As a result, we can reuse the same configs. So what I'll do in the next slide these can be configlets in CloudVision. So I'm just going to copy this. And I'm going to make a text box. It'll be GitLab mono, paste the config, shrink that config, make it white, and then remove all the parts that are not related to mlag. I'll make it bigger. Also, we'll do a different background. And then a border. I like that. More purple. Yeah, there we go. And the outline should be, the weight should be 1. Oh, they're semi-transparent. Let's not do that. There we go. So we just swap those two. There we go. Call this odd switches. And even switches. So all your odd switches will have the left config, all your even switches will have the right config, and it'll work just fine. Because again, we don't send that VLAN 4094 beyond the mlag domain. Now you don't have to. You can give them individual peer links, peer IP addresses, but they're not necessary. Did I do no auto state? I should do that there. There we go. So we have the option. We don't have to, but we can. Another thing about them. mlag IDs. So get rid of all the animations for this slide. Maybe I'll move this down. Move this up or across. Move this up. Hard to tell which one works better. Burp. Or maybe just not. Yeah, maybe I'll just make this a... that, and that. Put these both back in the middle. Group it. Okay, so each one of these is going to have a system ID. Maybe I make the text smaller. Or I'm going to keep things consistent. So system ID here and here. Doop. So they're going to have two different system IDs, unique system IDs. But we need a shared bridge ID for spanning tree and shared system ID for LECP. We'll do some animations here, up here, then animation pane. I can do effect options, text animation. Yeah. So we need a shared system ID. So there is an election. I need to make a slide talking about the 7th bit. And before I do that, I'm going to take a restroom break. I'll be right back. My allergies are acting up something fierce, which makes me cough, which just the way my body works, because I get postnasal drip. It was fun during COVID, because I'm always coughing in the summer. So everyone thought I had COVID, but it was just allergies, except when it was COVID. All right. Speaking of which, I'm going to go grab my allergy meds, and I'll talk to you while I'm doing that. So there's two different types of MAC addresses. Well, four different types. So there's unicast and multicast MAC addresses. So there's ranges for each one, but there's also local or locally administered MAC addresses and globally administered MAC addresses. And you can tell by looking at the second digit in the first octet of a MAC address. For those listening, could you hear that whole spiel? Because I walked to my bathroom for my medicine cabinet to get my allergy meds. Just over-the-counter stuff. So locally administered, So a little bit going over a MAC address in general. How did I do this before? Did I do this before? Pretty sure I've done this before. See if I can see what I did. Yeah, I know I did it, but I think I did it with IPv6 addresses as well. No. All right, so how do I convey this information? So MAC address is going to be the center, and then I'll do get lab mono. Make this big. So two parts of a MAC address. No, don't want to fill that. Want to, yeah, there we go. Of course, we have the OUI. And I'm going to look up on MAC address. Yeah. Naked system. So MAC addresses, yeah, so then we look at the first octet. Grab a call out. Excuse me. Allergies. So this first part, there's a table. It was in the wiki. Like, what's the best way to... Yeah, so that's 048 and Charlie. Let's try this. Sometimes it's just a matter of figuring out what's the best way to convey a given piece of information. So it would be, actually, let's get rid of these. The column. Unicast, universal. Or and then add one more low. 8 and Charlie. So if you look at that second digit of the first octet of the OUI, probably put these in the center. And then put this in the center too. So if it's a 0, 4, 8, or Charlie, then it's going to be a universal unicast address, which means it's going to be burnt in to the chips. But we also have, so these are universal. Administered. This will be locally administered. So unicast. And so those are going to be 2, 6, alpha, and echo. I'm getting it from this chart here. It's basically is the 7th bit a 0 or a 1. That's how that's determined. And we only care about the multicast addresses. So what we do is there's an election. So MLAG primary and secondary. One of them becomes the primary, and you can specify which one becomes the primary or secondary. It doesn't really matter because the one that becomes primary is the one that sources all of the PDUs. So the LACP PDUs and the spanning tree PDUs, BPDUs, bridge PDUs, those are generated by whichever one's primary. And also the system ID is determined by taking the primary's address and flipping the 7th bit, which makes it a locally administered MAC address. So if I do show MLAG, we can see which one we are. We have the secondary. I think it's the lowest MAC address wins the election. Let's check the docs. If I remember right, it's the lowest MAC address. EOS MLAG config. When the appear like primary first, I'm looking to see it's primary and then dual primary detection. It doesn't really say. I mean, it might say in there, I just didn't see it, but I'm pretty sure it's the lowest MAC address. System ID, see there, so the other one, so this is 053 beta 6. And if I do show system, show version, So that's the local address. 05 73F. So that would be definitely, so 7305 and then 73F8. Yeah, so that would definitely be the lower ID. So that's why that one, yeah. So yeah, let's go over. Let's do a call out. And we'll do animations appear. And then appear. Okay. And then they'll both disappear. So then I'll make a little thing that says primary. Malg. It's like gagging malg. We'll do animation. So that means this one's the primary because it's the lowest ID. And then the we'll have a shared mlag ID. Make this big. Make it white. Be shared system ID. Be 02 1 Charlie 73000001. I'll have another call out. It's the first octet. We flip the 7th bit. All right, so, and then this will be an appear. Animations, appear. Okay, so this is how I do it. So we've got 2 system IDs on each switch. Each switch was going to have its own unique system ID. This one has 001 Charlie 73, all zeros except 1. This one has 001 Charlie 73, all zeros except 2. Now there's going to be an election to determine which one of these is going to be the primary, and the one on the left is going to win because we haven't specified a priority. We can specify which one we want to be priority, but honestly, I've never needed to do so. But because switch 1 is the lowest, that becomes the mlag primary. So they both forward data plane traffic. They both run their own control plane. The big purpose of the mlag primary is, one, we need to have a base system ID to base our shared system ID from, and all of the PDUs are going to come from switch. They're going to be generated by switch 1. So what happens is we take the first octet, we flip the 7th bit, which will make it, in this case, will make it a 02. So our shared system ID is going to be 02 1 Charlie 73000001. So that's how we come up with that system ID. And then I'll do this thing. And a new slide. I think this will be the last slide I'll do for today, at least for now. Maybe we'll come back to it a little bit later. But I've got to go for a run. PDUs from mlag domain. So the host, let's see, show LHCP peer all ports. Copy this. Paste it into there. So GitLab white shrink it. Shrinky dink. Like that. What? Purple? No. There we go. Shape fill. And then a call out. And then do another call out. There we go. Do a little linky. So make this appear. So we've got our switches here, and they're connected to a host. And on that port, on that switch, I run show LHCP peer, and then I see the system ID from LHCP, and it matches the system ID. Yeah, there we go. So the system ID I see here matches the system ID there. So that's where we get that from. And spanning tree works the same way. So let's see if I do a spanning tree. I don't need to do that. Okay. All right, I think that's good for today. It's 2 hours of slides. I got through quite a few. And I'll see everyone.